we're going to look at solving problems with quadratics. And we have a pretty long problem here. We'll read through it once, and then we'll highlight important stuff and go from there. So Maria and Nadia fire a toy rocket into the air from the ground. At 10 seconds, the rocket hits the ground. They know that after 2 seconds, the rocket was 20 meters in the air. Build the equation that models the rocket's flight path. Okay, lots of important info. First off, Maria and Nadia fire a toy rocket. At 10 seconds, the rocket hits the ground. Okay. They also said that they fired the rocket from the ground. Okay, though there's no numbers there, that's actually really important for us too. They also know, here's a different type, they know that after 2 seconds, the rocket was 20 meters in the air, and then the question asks us to build the equation. Okay, so we kind of have to label our important information. I'm going to quickly sketch like our plane here. And we have to label our x and y because that's going to help us decipher what is what on our x and our y. First of all, we have to figure out what do you think is the independent variable and what is the dependent. In other words, what would we put on the x-axis and what would we put on the y-axis? They've kind of told us what our variables be. One of them is seconds, and one of them, it looks like, because they put meters, is going to be height. So where do you think seconds would go?
On the x-axis?
That's right. So this is our seconds. Okay? And which means this is our height, or meters is being measured in. Okay? When they fire it from the ground, what second do you think they're at?
0.
That's right. So one of the x-intercepts is 0, 0. And when does it hit the ground?
10 seconds.
Aha, at 10, 0. So that's important for us. Unless this rocket burrows through the ground, it probably heads upward. And something tells us that actually heads upward. They told us at 2 seconds, it's 20 meters in the air. So it goes up, comes back down, and we know that, I'll write it in green here, at 2 seconds, it's at 2 and 20, okay? So that's an important piece of information for us too. We want to build the equation of this. So they've given us, let's talk about the important parts of the parabola they've given us. Have they given us the x-intercepts?
Yes.
Yep. Have they given us, I should end that bracket, have they given us the y-intercept?
Yes.
Yeah, they have. That's important. How about the vertex?
We could find it.
We could, but is it given to us right now?
No.
No. So if our goal is to build an equation, oh geez, what did I do there? If our goal is to build an equation, usually the best two to work with are either our vertex form, okay, we'll write it out, which is, do you use f at x?
Yeah.
Okay, good. F at x is equal to ax minus h squared plus k, or factored form, which is f at x is equal to ax minus r, x minus s, right? Mm-hmm. And each of these are easier to build depending on what information you have. Obviously, the vertex is easier to build if you have the vertex, and the factor is easier to build if we have our x-intercept. Since this question gives us x-intercepts, we're going to build using factored. Okay, so our factored form, we know f at x is equal to ax, which we'll call this r and this s, okay? So x minus r, and we're going to use the x values. Those are what are important to us, not the y values. X minus 0 and x minus 10, okay? So we plug those two in. This is good information. I can simplify this bracket. This bracket can be written as just ax, 10x minus 10. And that might look a little confusing to you. I'm going to work with it anyways, but if it was confusing, you could have just left it in brackets and worked with it that way, okay? I don't know, f at x. Now, the other important piece of information they gave us was 2 and 20, okay? And that'll help us solve for a. We know that one of the other x values was 2, and the y value associated with that was 20. So we can replace our f at x with 20, okay, is equal to, a is what is our unknown. Our other x was 2, and again, we'll fill in this 2, and then minus 10. Does it make sense what I've done here?
Yeah.
And the whole goal here is to figure out what our a is. Since we knew x and y, a is our only unknown left, we're going to solve for a so that we can finally build the equation, because that's our unknown. I'll write the rest in black here. So 20 is equal to, 2 times a is 2a. Okay, I'm going to write it like that, 2a. And 2 minus 10 is negative 8. So this is 2a times negative 8, which might look confusing, but all we do is multiply coefficients, okay? So we get still 20 is equal to 2 times negative 8 is negative 16a. The goal is to get a by itself, so how do we bring 16 over?
Make it positive.
Well, it's actually multiplication here.
Oh, okay.
So what would the opposite of multiplication be there?
Divide.
Yeah. So we divide by 16. Very good. So you get a is equal to 20 over 16, which is negative 5 over 4, or negative 1.25. There we go. Negative 1.25. So that's our a value. So what that means is we can now build our in our factored form. We'll write it over here. F at x is equal to, our a value was negative 1.25. You can use the calculator if you're unsure. X minus 0, x minus 10. Or the other way you could have written this, I'll still write it like that in red, negative 1.25. That's just x times x minus 10. Still technically the exact same things, okay? And we've built the flight path. We figured out what was important. We built the equation. I think that's all they wanted us to do.